The sun is 30% brighter today than it was when life first appeared on Earth, and it's getting brighter by about 1% every 100 million years. This isn't speculation. It's the physics of stellar evolution, and it means our planet has an expiration date. Not billions of years from now when the sun becomes a red giant much sooner. The oceans will boil, the atmosphere will be stripped away, and the process that makes this inevitable, it's already happening. The clock is running. So when exactly does Earth become uninhabitable? And is there anything that could change this timeline? For most of human history, we assumed the sun was eternal, a perfect, unchanging fire in the sky. Even early astronomers believed it would burn forever. Then we discovered nuclear fusion, and everything changed. The sun isn't burning fuel like a campfire. It's crushing hydrogen atoms together in its core. 4 hydrogen nuclei become 1 helium nucleus. The leftover mass becomes energy. Simple, elegant, deadly. Here's what most people don't realize. As helium accumulates in the core, the sun has to work harder. The core contracts slightly. It gets denser, hotter. Fusion rates increase. And the sun gets brighter. This isn't something that might happen. It's happening right now, every single day. The sun you woke up to this morning is imperceptibly brighter than yesterday's. But here's where it gets strange. This slow brightening creates a countdown that ends with Earth looking like Venus. Think of Earth's climate like a thermostat with a fatal flaw. Right now, our planet regulates temperature through the carbon cycle. More heat means more rain. More rain means more weathering of rocks. This pulls carbon dioxide from the atmosphere, cooling us down. It's a beautiful feedback loop. It's kept Earth habitable for 4 billion years. But this thermostat has a breaking point. As the sun brightens, Earth's surface temperature rises. Eventually, we hit a threshold around 70 degrees Celsius on average. At that point, water vapor floods the atmosphere faster than it can rain out. Water vapor is a greenhouse gas. More heat, more evaporation, more water vapor, more heat. This is called a runaway greenhouse effect. Once it starts, it cannot stop. Here's the number that should keep you up at night: 1.1 billion years. That's the current estimate for when this feedback loop begins. The oceans won't just warm, they'll boil into the atmosphere, then get stripped away by solar wind. Which leads to the part that most people never hear about. Venus isn't just a cautionary tale, it's a preview. Early Venus likely had oceans, maybe even conditions suitable for life. Then the sun brightened. Venus crossed the threshold. Its water vanished into space. Today, the surface temperature is 465 degrees Celsius. Hot enough to melt lead. That's Earth's future. But the timeline is even more compressed than that 1.1 billion year figure suggests. Complex life needs more than liquid water. It needs stable temperatures, functioning ecosystems, an intact ozone layer. Some models suggest complex life on Earth has only 500 to 800 million years left. That sounds like forever until you realize something. Life took 4 billion years to produce a technological civilization. If it takes that long on average, then we appeared just in time. A few 100 million years later and the window would have closed. Every intelligent species in the universe might face this same clock. So the real question is, does this change what we think is possible for life elsewhere? Right now, scientists are hunting for planets in the habitable zones of their stars. But here's what's changing. We're starting to factor in stellar evolution. A planet might be habitable today, but not in 500 million years. Or it might be frozen now, but habitable later. The James Webb Space Telescope is already analyzing atmospheres of exoplanets, looking for biosignatures. But researchers at Cornell and NASA are building models that track the habitable window for each system. How long life has to evolve before its star brightens too much. This changes everything about where we look. We're not just searching for habitable planets anymore. We're searching for planets where the timing is right. Teams are actively mapping which nearby systems might be in their equivalent of Earth's last billion years, because those worlds, if life exists there, would be under the same pressure we'll face. That sun rising over Earth right now, the same one that made all of this possible, is already slightly brighter than yesterday. And it will keep getting brighter until everything we know is gone. But here's what stays with me. We figured this out. A species that's existed for 300,000 years looked up, did the math, and understood its own expiration date. That's not tragedy. That's remarkable. So here's what I want to know. Given this timeline, do you think humanity, or whatever we become, will still exist when the oceans start to boil? Follow for more. We post every week.